C-I-R-C-U-I-T. Okay. I don't know how to spell circuit, obviously. That's pretty sad.
But you got it up okay on. You did spell it right.
All right. Wow. Brain not completely functioning properly. Okay.
What are those? People.
They're neurons. They're just really badly drawn neurons because I don't want to spend a lot of time on this topic. Okay, so what's this one?
That one is
Converging, okay? Whenever you think, I think of it like this. I think of a mob, okay, an angry mob. What does an angry mob do?
chase one person.
Goes after something, right? An angry mob comes, there's a whole bunch of people, and they come and converge on a building, right? Or a thing of bees, you know, a whole bunch of bees converging on something, or a whole bunch of predators converging on. So converging circuits. Converging circuits are many to one. Converging equals many to one. Make sense?
Mm-hmm.
Okay, cool. What about
When did we learn this?
Diverging?
2 weeks ago? Or was this last week? No, it was 2 weeks ago. Yes, diverging. One to many.
Oh, this is when we were on that thing. That's why I don't remember this.
Okay, so one presynaptic cell is going to affect many postsynaptic cells. Make sense?
Mm-hmm.
Yeah. Yes? The next one on there is reverberating, I think, right? So it doesn't really matter. Let's do reverberating. Reverberating. What does reverberating do? Reoccurs, it circuits, it bounces, it goes around and 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 around, but it still does affect a postsynaptic neuron that's going to continue going down. However, these postsynaptic neurons here, it's going to reverberate around and around and around. What is this usually used for? Short-term memory. Okay? If you think about it, you've got the same piece of information from this guy that's going around in a circle right here. The same information keeps going and going and going and going and going. You're going to remember it then.
So would that one would it go around and then one drop and then keep going? Or would you
Oh, it would keep going, but the signal would still be going down.
But it's still
Reverberate. Yep. Yep. And the time frame changes depending really on what it is. Okay? This is what you would use when you're trying to remember a phone number. If I were to give you a phone number right now and you were trying to remember it to get over to the phone and make a phone call from the phone, not from your
So
cell
we
phone.
kind of like repeating the phone over and over.
Mm-hmm. And it would be reverberating in your brain. Okay? Parallel after discharge. Sorry. Alright, so reverberating equals short-term memory. Okay? Parallel after discharge. This one's kind of interesting. Okay? after discharge, or I'm going to do parallel. Parallel after discharge. Now this one states that the presynaptic neuron, you see the axon collaterals coming off of it, hitting onto other postsynaptic neurons that hit onto the final postsynaptic neuron, but they're all going down the same path. Okay, so you're thinking about one thing, but there are many things inside of that one thing you have to think about. Okay, when I say to you, water park, what's the first thing that comes to your mind?
Water.
What? What did you say?
Water.
Both of you said water. Someone said something else.
Waterfall.
Waterfall. Anyone else? Think of something else. What? Rides, slides. Summer. Okay. Now, when I say, what would you do at a water park?
Get wet.
Okay, so but you're thinking of more than just one of those things at a time, aren't you?
Yeah.
But you can only really say one at a time, right? Okay, so you're thinking you've got one idea that branches into 3 or 4 different ideas that all converge, and you can only really say one thing at a time. Right? Does that make sense with parallel after discharge? Okay, so that one equals problem solving. Does that make a little bit more sense when it comes to circuits, neuronal circuits?
This one.
This one? Short-term memory. Long-term memory is a little bit, no, that's problem solving. Long-term memory is a little bit more intricate than just a reverberating circuit, and we're not going to get into that until we get to the brain. Okay? I'm not even going to think about that until we get to the brain. Okay, does that make sense? Can I cross this one off the list?
Mm-hmm.